Hey everyone, welcome to homework 6.6. The situations described here each have an outlier. For each situation, how would you determine if it is appropriate to keep or remove the outlier when analyzing the data? Explain your reasoning in a full sentence. Okay, so number cube has sides labeled 1 through 6. After rolling 15 times, Tyler records his data. What is the outlier? So here, obviously, the outlier is 20, right? Because that is much greater than all of the other numbers. And it says, should it be kept or removed? So this is the one that Ben mentioned in class today. And we're going to say that this should be removed because this, so remember, full sentence, should be removed because it is a 6-sided die and 20 is not on the dice. Okay, 20 doesn't make any sense if the dice is labeled 1, 2, 3, 4, 5, 6. Number 2, the dot plot represents the distribution of the number of siblings reported by a group of people. What is the outlier? The outlier is 12. Should it be kept or removed? So in this case, this should be kept because we don't have any evidence that this isn't true, right? So this should be kept because there isn't any evidence this is not true, right? It's quite a lot of kids, but it's totally feasible for somebody to have 12 siblings. Number 3, in a science class, 11 groups of students are synthesizing biodiesel. At the end of the experiment, each group recorded the mass in grams of the biodiesel they synthesized. So these are the masses. What is the outlier? Should it be kept or removed? So these numbers are all pretty close together. They're all 1 point something except for that 0. So let's go ahead and check, though, if it's the 0 or the 1.532 that's an outlier. All right, so to do this, I'm going to go to stat and I'm going to go ahead and enter my numbers in the list, which I've already done here. So you can see that that's already been done. And I'm going to determine what my number summary is. So let's go ahead and go to calc, variable statistics. All right, so for this, the thing that I most need are my quartile 1 and my quartile 3. So quartile 1 is 1.292 and quartile 3 is 1.482. All right, so now I'm going to use that to find the interquartile range. So 1.482 minus 1.292, and that is 0.19. So that's my difference there. That's my interquartile range. And then I'm going to multiply that times 1.5, because remember, that's the number we're using to determine if something is an outlier or not. And then I need to add that to either, I'm going to add that to one quartile. So I'm going to add that to plus 1.482. I'm going to add that to the third quartile, and I get 1.767. So anything above that is an outlier. That means that none of these are outliers because they're under 1.767. And then I'm going to take my first quartile, so it's 1.292, and I'm going to subtract 0.285, and I get 1.007. So anything less than 1.007 is an outlier, which means, as predicted, 0 is the outlier. All right, so should it be kept or removed? Well, it says at the end of the experiment, each group recorded the mass of grams of the biodiesel they synthesized. So does it seem likely that they would have a 0 mass of biodiesel? So in this case, I would say that this probably should be removed. And I'm going to type this just so that it's a little faster and clearer. I would remove this outlier because it seems unlikely that they would have 0 grams or biodiesel of a mass with 0 grams. Okay, I think I spelled biodiesel wrong. I did. Yep, biodiesel. Okay, so make sure again that you answer that question completely. Again, we use 1.5 times the interquartile range to find the amount that we add to quartile 3 or subtract from quartile 1 to see which numbers are either too big or too small and are therefore outliers. Number 4, the number of letters received in the mail over the past week is recorded 2, 3, 5, 5, 5, 15. Which value appears to be an outlier? So just by looking at this, we would probably say that 15 is the outlier, but I'm going to let you go ahead and decide that and circle that yourself. Make sure that you answer it. You should be listening. All right, Elena collects 112 specimens of beetle, interesting, and records their lengths for an ecology research project. When she returns to the laboratory, Elena finds that she incorrectly recorded one of the lengths of the beetles as 122 centimeters, about 4 feet. What should she do with the outlier, 122 centimeters, when she analyzes her data? So here, you're going to tell me what you think she should do. I think that Elena should ... and I want you to explain why here, okay? I'm not going to tell you. I think using this information, you should be able to determine what she should do. Number 6, a group of 20 students are asked to report the number of pets they keep in their house. The results are 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 2, 2, 3, 4, 4, 4, 21. Okay. So here is the data. Would any of these values be considered outliers? Explain your reasoning. So immediately I'm looking at this 21. That seems a little bit off, but let's go ahead and make sure that we've calculated correctly. So our interquartile range, or IQR, is 2.5 minus 0.5, which is just going to be 2. Then I'm going to multiply that by 1.5. So 2 times 1.5, which is going to give me 3. And I'm going to add that to Q3. So if I add that to Q3, 2.5 plus 3 equals 5.5. And that means anything greater than 5.5 is an outlier. So 21 would be an outlier. We also need to look at the lower end of things, right? So if quartile 1 is 0.5 and I subtract 3, I would get a negative answer, negative 2.5, but we don't have any negative results, so none of those would be outliers. So my outlier is 21 because it is greater than quartile 3 plus the IQR times 1.5. In other words, it's greater than 5.5. After being told that they would not count any fish in the report, the value of 3 becomes a 2. All right, so this value becomes a 2. And the value of 21 becomes 1. So apparently this person had 20 fish, okay? And they counted all 20 fish as part of their pets. Would these changes affect the median, mean, standard deviation, or interquartile range? If so, would each measure decrease or increase from their original value? So here's what I want you to do. I want you to tell me median, yes or no. Mean, yes or no. Standard deviation, yes or no. And IQR, yes or no. And I want you to tell me if it's going to increase or decrease. So median, if we were to change this to 2 and we were to change this to 1, what would happen then is this 1 would be moved to the other side, right? So this data would now look like this. So if we're going to our median, we would count 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our median is still going to be 1. It's the same. So actually we would say for median, no increase or decrease. Then the mean, which we have as 2.4 pets, would that change? Yes, it absolutely would. And since we're lowering 2 of the numbers, it would decrease. Our standard deviation then would change, and it would also decrease because now our numbers are closer together, right? And because standard deviation is dependent upon mean, it would definitely decrease. Now our IQR we found to be 2.5 minus 0.5, right? An IQR of 2. In this case, this would be our median, and so our new interquartile range would be 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So our interquartile range would still be, our Q1 would still be 0.5 on this side. And on this side, it would be 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. It would be 2. So in this one, our quartile 3 would, 1, 2, 3, 4, 5. Let me make sure I calculated right. Yep. Our interquartile range would be a little bit smaller because quartile 3 would be 2. So yes, by a little, it would be 1.5 instead of 2, so it would also decrease. All right, that is it for your homework today. Very short. And so your code word today is turtle, since we are talking about pets. Turtle. Happy homeworking and see you tomorrow.